I gave you 2 practice exams. Basically, we're going to do one in class, and the other one you can do it at home, but you have solution. In the last 2 questions of exam 2 are the hard question. So, so in all of my tests, there will be hard questions, and you can get extra points for those questions, right? So those are the hard questions that you can try, because those are the thing that I don't teach in class. So I mean, it's up to you to solve it. But if you can solve it, you get the extra points. All right. So let us start with the first practice test. So exam practice 2. Questions number 1. Verify that the given set is a set of solutions for the homogeneous equation and that XP is a particular solution. So initial value problem. All right, so in this case, you have what? You have t squared x second minus 2t x prime plus 2x is 2t cubed. x1 is 2, x prime at 1 is 3. So the set is t squared and xp is t cubed. Right, so solution. So in this question, the first question is trivial, because I asked you to verify that those are the solution of the equation. So basically what you have to do is just plug them into the equation, and you see that they are solutions. All right? The first question is the most is the easiest one to give you points. All right, so now we're gonna have to check. The first thing is that the set of solution, the given set, which is this set, all right, is a set of solutions for homogeneous equation. All right. The first question is that, okay, you have to check this set is a set of solutions for homogeneous equation. So what should we check? Yes.
We plug t into the equation and make sure that the left side comes out to 2t cubed, and then we plug t squared to the left side of our. Oh, I'm sorry. That's not the homogeneous equation.
Right.
We need to write the homogeneous equation first. We need to set the right side to 0, and then we plug in t and t squared, and
Yes,
we
thank you.
get 0.
So what we do is that we plug t and t squared into the equation with 0 on the right hand side. All right? It's clear? So so you're gonna plug it. So we check that t and t cubed are solutions of t squared x second minus 2t x prime plus 2x is equal to 0. All right? So you check that t and t squared, they're both solution of homogeneous equation. What you do is that you plug t and t squared into the homogeneous equation, and you see that they are the result is 0. All right? So let's check. We have t squared. Now let us start with t. So t squared t second minus 2t t prime plus 2t is what? So what is the second derivative of t? Yes? Yes? 0, yes. So, can you sign the back of paper, please? So the second derivative of t is 0, right? What is the first derivative of t? Yes? 1, yes. Can you sign the back of paper, please? So you have 2t times 1 plus 2t. Right? So here you have 0, right? The first thing you do is you plug t into the equation, and the homogeneous equation. So you see that t second is 0, t prime is 1. So when you plug everything into the equation, you get 0. All right? It's clear. Now you have to check t squared. You have t squared second minus 2t, t squared prime plus 2t. So what is the second derivative of t squared? Yes?
2.
Yes, no. Yes, can you say the back of paper, please? So the second derivative of t squared is 2. What is the first derivative of t squared? Yes?
2t.
Can you say the back of paper, please? So you have 2t times 2t plus 2t. Did I make a mistake somewhere? Yes, t squared, sorry. All right, so you plug t squared into the homogeneous equation. You see that t squared second derivative is 2, t squared prime is 2t. So you plug everything into the equation, you get 0, because you have 2t squared minus 4t squared plus 2t squared, and you get 0, right? So basically, we know that t and t squared, they are solution of the homogeneous equation, right? So the next step is to check that xp is particular solution of the equation. So what should we check? You want x? Yes?
We plug xp into the differential equation and see that it's a solution.
Yes, can you send the back of paper, please? So you have to check xp. You want to know that xp is a particular solution of the equation. You just plug xp into this equation, and you see that this is 0, right? So now you have xp, which is t cubed. xp is t cubed, right? So what you do is you plug t squared t cubed second minus 2t t cubed prime plus 2t cubed. What is the second derivative of t cubed? Yes?
60.
Can you sign the back paper, please? So the second derivative of t cubed is 60. What is the first derivative of, yes?
30t squared.
Yes, can you sign the back paper, please? So you have 2t times 3t squared plus 2t cubed. Right? Yes. So what is the result? What is the final answer? Yes? Can you send the back to paper, please? So the final result of this is 2t cubed, which means that t squared plus x second minus 2t xp prime plus 2t plus 2xp is 2t cubed, right? So you plug xp into the equation. You get 2t cubed, which means that t squared xp second minus 2t xp prime plus 2xp is 2t cubed, right? And basically this is the particular solution. All right. Any questions? Right. Now, so you have the two solutions of the homogeneous equation. You have the particular solution. What is the general solution? Yes?
X equals t cubed plus c1t plus c2 t squared.
Yes. Can you say it back, please? Right. So now we the general solution will be xt will be xp t plus c1 t plus c2 t squared. So this is t cubed plus c1t plus c2 t squared. this is the general truth, yes?
Is it all right on the exam if we just write out that the general solution will be the form of the particular solution plus the solution to the associated homogeneous equation? We don't need to derive that by subtracting.
No, you don't have to. You just write this formula, right? So you don't have to subtract. To the derivation it was to understand where the solution comes from. But in the exam, you just write out the general form of solution. You don't have to prove it again. All right? So as long as you know how to compute it, it's fine. You don't have to derive it again. Now you have xt is t cubed plus c1t plus c2t squared. The next step is that you have the two initial conditions, right? Now what should we do? Yes?
Solve for the constants by plugging in the numbers that you have.
Yes. Can you sign the back paper, please? So the next step is to solve for the two constants c1 and c2 using those initial conditions, right? So solving for c1 and c2, right? So you have x1 is equal to 2. That means 2 is equal to 1 cubed plus c1 times 1 plus c2 times 1. So we have 1 is c1 plus c2. Alright, so the next step is that you have to solve for the two constants, c1 and c2, using the initial condition. You know that x1 is 2, so what you do is to plug 1 into the general solution to solve for c1, c2. So when you plug 1 into the first condition, you have 2 is 1 cubed plus c1 times 1 plus c2 times 1. So you simplify it and you get c1 plus c2 is 1. Alright? So the next one is to use the second initial condition. So to use the second initial condition, you have to take the derivative. So what is the derivative of this guy? Yes?
The derivative of x of t is 2t plus c1 plus 2c2t.
Yes. Inside the back of the paper, please. So you take the derivative of this guy, you get 3t squared plus c1 plus 2c2t. All right? Because the second derivative, the second condition is about the derivative 1. So you have to take the derivative of the general solution. Derivative of the general solution is 3t squared plus c1 plus 2c2. And now you have x1 prime 1 is 3. So 3 times 1 squared plus c1 plus 2c2 is 3, which means that c2 plus 2c, c1 plus 2c2 is 0. So you arrive at the equation. All right? Questions? Right. So I explain again. The second initial condition is about the derivative of the solution at 1. This is why here you have to take the derivative of the general solution that we found. This derivative gives you 3t squared plus c1 plus 2c2t. All right? So you know that x prime at 1 is 3. You plug 1 here. You will have that 3 times 1 squared plus c1 plus 2c2 is 3. You eliminate the 3. You have c1 plus 2c2 is 0. All right? You put the two conditions together, you have a system. So how do I solve this system? Yes?
You can do the first one minus the second one.
Yes.
And that'll give us c2 equals -1 and then plug that back into the first one.
Can you sign the back of the paper, please? So you minus this one and this one, right? So you have c1 plus 2c2 minus c1 plus c2. 0 minus 1. So 2c2, c2 is minus 1. All right, so to solve this system, you subtract the second one with the first one. When you subtract the second one with the first one, you get c1 plus 2c2 minus c1 plus c2. So here you have c1, c1, you have 2c2, c2. The final result is c2. You have 0 minus 1, and this is minus 1, right? How do I find c1? Yes?
Plug C2 into the first equation.
Yes, can you sign the back of paper, please? So you plug C2 into the first equation, right? So you have C1 plus C2 is 1, which means that C1 plus minus 1 is 1, so C1 is 2. All right? So now what is the general form of the solution? Yes?
X equals t cubed plus 2t minus t squared.
Yes, can you stand the back of the paper, please? So, so here you're gonna get xt is going to be t cubed plus plus 2t minus t squared. All right. So you plug C1 and C2 into the form of resolution, and you obtain the new form with the exquisite C1 and C2. Questions? It's clear? So the first question is the easiest one because you don't have to solve anything. You just plug the solution into the equation and you see that there's 0 and that's it. All right? But you have to check. The only thing you have to solve is the constant. All right? So you have to solve the constant, but solving the constant is easy because you have a system of 2 equations, and those are not difficult to solve. Questions? It's clear? So the structure of the exam will be like this. First one is to check the solution. So the second one verify that x1 is a solution and find x2. T x second plus t minus 1 x prime minus x is equal to 0. x1 is e to the power minus t. All right. Now, I give you the equation. I ask you to check this is a solution, and I ask you to find the second solution. So what is the method that we are using here? Yes? Yes. Can you start the back of the paper, please? So this is reduction of order. All right. So for this exercise, you gonna one solution is no, and you have to find the second solution. And to find the second solution, you're gonna consider the ratio between the second and the first solution, and you find an equation for this function. All right. And this is the reduction of order method. So first you check x1. So in order to check x1 is the solution of the equation, what should I do? Yes?
You plug it in, so you find the first derivative of e to the negative second.
Yes, can you send me back the paper, please? So you want that t e to the power minus t second plus t minus 1 e to the power minus t prime minus e to the power minus t. And you want this to be 0. So what is the second order of e to the power minus t? Yes?
E to the power minus t.
Can you just hand the back of the paper, please? So the second derivative of e to the power minus t is e to the power minus t. What is the first derivative? Yes?
Negative e to the power minus t.
Can you just hand the back of the paper, please? So now you have minus 1 e to the power minus t minus e to the power minus t. And this is 0. All right? So the first step is always the easiest step because you have to put the solution into the equation and you check that this is 0. So here I plug e to the power minus t into the equation. I take the second derivative of e to the power minus t again. e to the power minus t. I take the first derivative of e to the power minus t, and I get minus e to the power minus t. All right? Questions? Right. So now I have to find the second solution. How do I find the second solution? Yes?
We denote v equals x2 or x1, so x2 plus vx1.
Yes. Can you say at the back of the paper, please? So to find x2, we will find v, which is x over x1, right? So to find x2, what we do is that we find v, which is equal to x2 over x1, instead of finding x2, right? So in this case, x2 will be v times x1, and this is v times e to the power minus t. All right? So what should I do now? Yes?
Assuming that you're solving for x2, you replace all the x's in the original equation with x2, and then you take the derivatives as needed to find the equation.
Yes, can you stand the back of the paper, please? So you're gonna plug this into the equation, right? So you have t x2 prime minus t plus t minus 1 x2 prime minus x2 is 0. So you're gonna have t v e to the power minus t second plus t minus 1 e to v e to the power minus t minus v e to the power minus t, and this is 0. So what is v e to the power minus t prime? Yes?
It's v times negative e to the negative t plus v prime times e to the negative t.
Can you say at the back of the paper, please? So to compute this one, you're going to use the chain rule, right? Plus v e to the power minus t prime. Product rule, sorry. To compute the derivative of v e to the power minus t, what you do is you use the product rule. You take the derivative v times e to the power minus t plus v times the derivative of e to the power minus t. Right, so you get v prime e to the power minus t minus v e to the power minus t. All right? Now I have to take the second derivative. So how can I do the second derivative? Yes?
By doing the product rule and twice.
Yes. Can you sign the back of the paper, please? So you're gonna have to do the product rule again twice. All right? So what is the derivative? First, the derivative. Yes?
We'll get v second prime e to the negative t plus v minus v prime e to the negative t.
Yes. Can you sign the back of the paper, please? So the first one gives me v second minus times e to power minus t, e to power minus t v prime. All right? What is the derivative of the second guy? Yes?
We'll have minus v prime e to the negative t plus v e to the negative t.
Thank you. So can you sign the back of the paper, please? So then you have v e to the power minus t, right? Now you have to do the second derivative of this guy. To do the second derivative of this guy, you're gonna take the first derivative of this guy. So you're gonna split it into two derivatives. The first one is v prime e to the power minus t prime, and the second one is v e to the power minus t prime. First one gives me v second e to the power minus t minus e to the minus t v prime. The second one is v prime e to the power minus t plus v e to the power minus t. Right, so how can I simplify this? Yes?
You can add the two terms, the negative e to the negative t times v prime, to get negative 2 times e to the negative t.
Yes. Can you sign the back of the paper, please? So now I have v second e to the power minus t 2 times v prime e to the power minus t v e to the power minus t. Right? So we're gonna put everything into the equation, right? So I have t times v second e to the power minus t minus 2v prime e to the power minus t plus v e to the power minus t, and plus t minus 1 v prime e to the power minus t minus v e to the power minus t minus v e to the power minus t, and this is 0. All right? So what should I do next? Yes?
Because e to the negative t is always positive, can we divide it out from every term?
Yes. Can you sign the back of the paper, please? Right, so I'm gonna divide everything by e to the power minus t, right? So I have t v second minus 2v prime plus v plus t minus 1 v prime minus v is 0. All right? Questions? It's clear? So what is the next step? Right. Yes?
You would distribute all the terms you have and cancel like terms, and then substitute omega for v prime and omega prime.
Can you say the back of the paper, please? So I'm gonna group all of the first derivative together, all of the second derivative together, and all of the v together, right? So the second derivative is t v second. There's no other terms. The first derivative will be here and here, right? So here I'm gonna have minus 2t v prime plus t minus 1 v prime. All right? I'm going to group all of the first derivative together, all of the second derivative together, and all of the v together, right? So the v will be tv minus t minus 1 v minus v is 0. All right? I explain again. After I plug x2 is v times e to the power minus t to the equation, I can simplify everything into this equation, right? So in this equation, you see that there is e to the power minus t everywhere. To simplify things, I'm gonna divide everything by e to the power minus t. And this is what I get after dividing by e to the power minus t. After I get here, I'm gonna group all of the second derivative together, all of the first derivative together, and all of the v together. Now, what should I, can I simplify this another time? Yes?
You can, so for the bottommost term, if you multiply that t minus 1 times the v, you will see that you will get a negative vt that will cancel out the positive vt, and you'll get a negative v that, a positive v that will cancel out your negative v, so that whole term becomes 0.
Mm.
And then you can do the same to the top, and you'll get v prime t minus v prime.
Yes, can you sign it back to the paper, please? So now I'm gonna see that this term is 0, right? So we have t v second plus minus 2 plus t minus 1 v prime, right? So I'm gonna put v prime as the common factor here. I'm gonna get minus t plus t minus 1 v prime, and the second, then the last term will be t minus t minus 1 minus 1 v, and this is 0. All right? I put v prime to be the common factor here. So I'm gonna get minus 2t. Here I have t minus 1, so I have t minus 1. And here I put v to be a common factor. I'm gonna get t minus 1 minus 1. All right? But this gives me 0. And the other term gives me minus t minus 1. V prime is 0. Alright? I explain again. After I divide everything by e to the power minus t, I group all of the v second together, all of the v prime together, all of the v together. Alright? I put v prime to be the common factor for minus 2t plus t minus 1. I get minus t minus 1. I put v to be the common factor in the last term. This gives 0. Alright? So I arrive at this equation. How can I solve it? Yes?
You can set w equal to v prime and make it a first order.
Yes. Can you stand by paper, please? So now we put w to be v prime, and this becomes a first order equation. So you have w prime minus t plus 1. W is 0. Alright? How can I solve this equation? Yes? Yes. So this is a separable equation, right? Because the t and the v can be separated. Can you stand the back of the paper, please? Right. So now you have t w prime is t plus 1 w, which means that t dw over dt is t plus 1 times w. All right, you have t w prime is t plus 1 w. This is separable. What I do is I write w prime to be dw over dt, and then you divide w to the left hand side, and on the right hand side you have t plus 1 over t dt, and this is 1 plus 1 over t dt. Is it good? Questions? Right. So I have tw prime is minus t plus 1 w is 0. So this is tw prime is t plus 1 w. W prime is dw over dt. I divide w over here, and I put all of this guy to the right hand side. So I have dw over w is t plus 1 over t dt, and this is 1 plus 1 over t dt, right? Questions? So how do I solve this equation? Yes?
We can integrate both sides to get the left-hand side will become the natural log of w, and the right-hand side will become t plus the natural log of t.
Can you stand the back of the paper, please? So now I'm going to integrate, right? So I integrate both sides. 1 plus 1 over t dt. All right? So the left-hand side will give you log of w. The right-hand side will give you t plus log of t plus constancy. All right? Now how can I find w? Yes? Yes, can you sign at the back of the paper, please? Now you want to take the exponential on both sides, so you have e log of w is e to the t plus log of t plus c. All right. So now you have e. So the absolute value of w will be e to the t times the absolute value of t times e to the c. All right. I take the integral on both sides. 1 over w will give you log. 1 will give you t. 1 over t will give you log t. And you have to add a constant, right? Now you take the exponential on both sides. You have e log w plus e to the t plus log t plus c. So this one gives you the absolute value of w. E to the t is here. E to the log t becomes the absolute value of t, and here you have e to the c, right? So you can put all of the sign into the c tilde, and you get this one. All right. again, here you cannot say that, okay, I have an implicit solution and you leave it right here. This is not good because you are supposed to find x2. So you have to have an explicit solution, right? So stopping here is not good. So if I ask you to solve an equation and you said that the solution has an implicit form like in the previous test, it's fine. But for here you have to find w because at the end you have to find x2, right? So you have to go until the end. This is w. How can I find v? Yes. Yes. Can you say at the back of the paper, please? Right. So now you have to find v. So because w is v prime, right? So v prime is c tilde e to the t times t. V will be the antiderivative of this guy, right? So how can I find this one? Yes?
Could we use separation variables?
No.
I mean, not separation variables. I'm forgetting the method, but it's the one where you have the integral of u dv is equal to u times v minus the integral
Yes. Can you
of
say at the back of the
v
paper?
du.
So you're gonna use integration by part, right? So you have u dv is uv minus v du. So this is integration by part. So here you have to compute this, all right? So this gives you, now I have to compute this guy. I know that et dt will be det, t d et, right? Right? So you have what? You have det is et dt. In general, v of a function v of t will be v prime dt. Right? So in this case, so this is the notation. So you have det is et dt. This is like dv is v prime dt. Right? So here you know that, okay, I can put et and et together. And I can write this like dt, t det, right? Questions? So this is u, and this is dv. All right. So I integrate this, I'm gonna get uv. I'm gonna get uv, which is t et. This is uv, and then minus v du, minus v du. Which is e to the t dt. This is v, this is u. All right? Here I use integration by part. So I explain again. I have et t dt. I put et dt together, I get t d et. Remember that, what is the definition of dv? Definition of dv will be v prime dt. Right, so here the derivative of et is et. So et dt is et, d of et is et dt. All right. Now I use integration by part for u and dv. U is t and dv is e to the t. So when I apply integration by part, I have uv. So here I have t et minus v du. V is et, u is t. So this is et dt. So what is the next step? Yes?
The integral of e to the t.
Yes, can you say at the back of the paper, please? Now you have to take this integral, but this integral is explicit. This is x. This is et plus a constant, right? So this is et minus et plus a constant t. All right. So this is v. Questions? So you know that W is V prime, so this is V W. So in order to find V, you have to take the integral of W, which means that you have to take the integral of et dt. So et dt, I can group et and et. So det will be et dt. So here I have t det. All right, this is u and this is dv. Now I can group u and v. I get TET. I have v du according to this formula, right? So here I have et, which is v, du, which is dt. The antiderivative of et dt is et plus a constant c. So basically I have this formula for v. So v will be c tilde t et minus et plus c. Right? It's clear? Questions? So how can I find x2? Yes?
Multiply that by x1.
Yes, can you send the back of paper, please? So to find x2, I'm gonna have to multiply that by x1. What is x1? x1 is e to the power minus t, right? So x2 will be c tilde e to the power minus t, t minus et plus c. All right? Now I am multiplying e to the power minus t inside, and I get c tilde t minus 1 plus c e to the power minus t. And this is x2. Right? I explain again. So after doing the integration, I obtain v tilde, which is of this form. So x2 will be v times x1. I multiply this quantity with e to the power minus t. Now I distribute e to the power minus t to each term here. So I get c tilde t, because t times e to the power minus t is t. I get minus 1 because e to the power minus t times e to the t is 1, and the last term is c e to the power minus t. Questions? Right. So the second problem is to find the second solution using the first solution, and this is the reduction of order method. Questions? Okay. Right. So let us try to solve. Let us try to solve the third equation. Third questions. Any questions on this? Question number 3. Solve this equation. X second minus 16 x is the solution. All right. Yes.
I just had one question about the previous problem. In the book, when it defines v, obviously it just sets it to the general solution over x1 instead of x2 over x1, and then it solves using the reduction of order the same way. Is that also an acceptable way to do the problem? Because the general solution, if you solve for the general solution and then you just said we can see that the general solution we know will be the form c1 times x1 plus c2 times x2, because we know x1, we can tell which one is x2. If we use the reduction of order method to find the general solution as opposed to finding the second solution?
This is a very good question. Yes. So basically, this is yes. Can you hand the back of the paper, please? Very good questions. Right. So this is x2, right? But this is also the general solution because here you have two constants, right? So let me write. So this is x2. C tilde t1 minus 1 plus c e to the power minus t. This is x2, right? But this is also the general solution. Why? Because the x1 will be e to the power minus t, right? So the general solution will take the form x to be c1 x1 plus c2 x2. All right? So when you plug c1 x1 plus c2 x2, you get c tilde t minus 1 plus c e to the power minus t. And I said that this is also x to y. Basically, x2 is x2, but this is also the general solution. Why? I mean, I can write the general solution in the form x2. How do I write it? Yes?
Because we could combine the e to the, if we multiplied c2 times c tierra times that term with the e to the negative t, we can combine all the constants into one.
Yes.
Yes. And then we can add that to the term c1 times e to the negative t, because again, the constants, it would be 2 times that, but we don't care about our constants. So
Yes,
we can
yes.
combine all that, and that would give us our first solution. And then the second solution is just a constant times t
right.
minus 1.
Can you send the back of paper, please? So basically, you can absorb this here because if you put c2 tilde to be the common factor, right? So you have c1 over c2 c tilde e to the power minus t, c2 c tilde t minus 1 plus c e to the power minus t, right? I'm gonna put this guy and this guy together. So I have 2 c2 c tilde t to the power minus 1 plus c e to the power minus t plus c1 over c tilde e to the power minus t, right? I put c to c tilde to be the common factor outside, and I have t minus 1, which is this term here, c e to the power minus t, which is this term here, but this term can be put inside, right? And now I have to group, because here I have t to the power minus t, e to the power minus t, so I can group this to be one constant. Right? I don't care about a constant. So basically, this form and this form, they're the same. Right? The constant here is the same with the constant here. You can put anything there, and the constant here and the constant here, they're the same. Right? So basically, the general solution will have the same form with x2. All right? Yes?
Will all these problems that are going to be on the test be homogeneous?
No. The fourth question is non-homogeneous. Right.
The first 3 are.
Yes. So basically, the first 3 is homogeneous, right? So if you check the second practice test, the first one is the first one is inhomogeneous, right? If you check, the first one is inhomogeneous. The first one is inhomogeneous, but I give you all of the solutions. You have to find the constant. The second one is homogeneous and reduction of order. Third one is characteristic method. The fourth one is inhomogeneous and undetermined coefficient. So if you check in the second practice test, you see this structure. All right. So let us solve this equation. So what is the characteristic equation for this equation? Yes?
R squared minus 60.
Can you send the back of the paper, please? So the characteristic will be r squared minus 60 is 0. Right? For this one, what are the 2 rules? Yes?
4 negative.
Yes, can you sign the back of the paper, please? So here I can factorize like r minus 4, r plus 4 is 0. So basically you have, the first one is 4 and the second one is minus 4, right? What are the 2 solutions? Yes?
E to the 14 and e to the negative 14?
Yes, can you sign the back of the paper, please? So the first solution will be e to the 40, e to the power minus 40. Right, so the general solution will be c1 e to the 40 plus c2 e to the power minus 40. Right. So the third question is also easy if you remember the formula. So I just ask you to remember the formula and apply it to this specific case. Questions? Yes?
Does it matter, like, say if I did R1 equals e to the negative 4t instead of just 4t, like if I flip the r's, does that matter?
So I will just flip this and this, right?
Yeah.
It's fine. It's fine. Yes?
Does the solution have like cosine and sine when it's an imaginary number, right?
Yes.
Okay.
Other questions? Right. So so let us solve question number 4. So you have x7 minus 7x prime plus 3x e plus 5 e to the 40. Solutions. Right. So what is step 1? So this is inhomogeneous equation. How can I solve an inhomogeneous equation in the first place? Yes?
Find a particular solution.
Yes, can you sign the back of the paper, please? This is step 1. Particular solution, right? All right, so screen questions? So what is the form of the particular solution in this case? Yes?
Well, the degree of our forcing function on the right is 1, so it will be xp is equal to, first I guess we'll do the e term. It'll be e to the 4t times t to the k times a naught plus a1t, and then for k we have to find the multiplicity.
Yes, can you assign the back of paper, please? So this is the table on case 3, right? But the table was wrong. I corrected the table on Tuesday, right? So the table was wrong because here you have to have t to the k. The degree of this guy is 1. So here you have to have a degree 1. Right? So this and this, they have to have the same order. So this is case number 3, when you have a polynomial times an exponential. This polynomial is of order 1. I have to translate this down here to have a first order polynomial. So this is a first order polynomial. I don't know a0, I don't know a1. All right? So let me put like in the table, this is capital I. And here I have e to the 40. So in the table, there was no e to the 40, and this is wrong. You have to correct that. I mean, be careful when you use that table in the exam, right? Right. So what is k? Yes?
The multiplicity of 4 is a solution of the characteristic equation.
Yes. Can you sign the back of the paper, please? So k will be the multiplicity of 4, which is this power here, right? So k will be the multiplicity of this 4 as a solution of the characteristic equation. The characteristic equation. So what is the characteristic equation in this case? Yes?
R squared minus 7r plus 12.
Yes, can you sign the back of the paper, please? So you have r squared minus 7r plus 12 is 0. All right? Right, so what are the two solutions of this guy? Yes?
4 and 3.
Yes, can you sign the back of the paper, please? So again, we use the trick that we mentioned before. You're going to find R1 plus R2 to be 7 and R1 times R2 to be 12. right? So this can be computed right away. So you find two numbers whose sum is 7 and product is 12. So this should be 4 and 3. All right. So which means that 4 is a solution of this equation. What is the multiplicity of 4? Yes.
1.
Yes. Can you say the back of the paper, please? So the multiplicity of 4 is 1. So k is also 1. Right? So you have xp is going to be t a0 plus a1 t e to the 40. Right? So this is the meaning of the name undetermined coefficient, right? Undetermined coefficient. So this is the meaning of the undetermined coefficient method, because here you have two coefficients to determine a0 and a1. Right? So I explain again. Here you have to know what is k. K is the multiplicity of the number 4 here as the solution of the characteristic equation. So the characteristic equation is r squared minus 7r plus 12. To find the two solutions of the characteristic equation, you try to find two numbers whose sums is 7 and product is 12. Those are 3 and 4. So you see that 4 is the solution, which means that the multiplicity has to be 1, and you replace k to be 1 here. You want to get t a0 a1 e to the 40, right? And this is the this explains the name undetermined coefficient, because a0 and a1 they are undetermined coefficients. Questions? Now I have to find a0 and a1. How do I find a0 and a1? Yes.
I'm gonna put XP into the initial.
Yes. Can you sign the back of the paper, please? Now I'm gonna put xp into the equation, and I try to find a1 and a2. Right. So I have what? I have xp second minus 12, 7 xp prime plus 12 xp is t plus 5 e to the 40. All right. You plug xp into the equation and you try to find a0 and a1. So what is xp prime? This is t a0 plus t squared a1 e to the 40 prime. All right. So what is this derivative? So I'm gonna yes.
It would be the first term we can just take down by itself, and then the derivative of the second term, which will be 4 times e to the 4t, plus the derivative of first term, which will be a0 plus 2a1 times t, and then that times e to the 4t.
Can you sign the back paper, please? So you wanna use again the product rules, right? So this is the derivative of the first term plus the derivative of the second term times the first term. Right. So I'm gonna take the first derivative times the second function, and the first function times the second the derivative of the second function. Right. So here I'm gonna get a0 plus 2t e to the 4t. Derivative of this guy is 4, so I have t a0 plus t squared a1 times 4 e to the 40. All right. So I'm gonna group everything, right? So this is a0 plus, so here I have 2t a1. So I have t times 2a1 plus a0 plus t squared a1 times this is a0 2 plus 4a0 plus 4 times A1 e to the 40. Alright? I explain again. I'm going to take the derivative of this guy. Alright? I take the derivative of this guy. I'm going to take the derivative of the first term times the second term plus the derivative of the second term times the first term. The derivative of the first term is A0 plus 2ta1, right? The derivative of this guy is 4 times of e to the t. Now I group everything. So here this is A0, which is a constant. I'm going to group this t here and this t here. So this gives me 2a1 plus 4 times a0. All right? So here I have 4a0 plus 2a1. And here the leftover is t squared. And here I have 4. Remember that we have 4. So I have t squared 4 times a1. It's clear? This is the hardest questions because this is a lot of computation. Right? So I have to take the second derivative of this guy, which is even more. So I have to take xb second. This is a0 plus 2 times a1 plus 4 times a0t plus 4a1 t squared e to the 40 plus. So this is the derivative. And then you have a0 plus 2a1 plus 4a0t plus 4a1 t squared e to the 40 prime. All right? I have to take another derivative of this guy. To take the derivative of this guy, I take the derivative of the first guy times the second guy plus the first guy times the derivative of the second guy. Right? What is the derivative of the first guy? No, this derivative. Yes?
Then 1 plus 4a0 plus 2a1 plus 8a1?
Yes. Yes, can you sign the back of the paper, please? So you're going to take the derivative of this guy. You get 2a1 plus 4a0. Alright, plus 8a1t e to the 40, right? And then you have to take the derivative of this guy, but this is the same with before, it's going to be 4 times. Plus 4a1t squared times 4 times e to the 40, alright? Questions? Right, so the derivative of the first guy is 2a1 plus 4a0, and this gives me a times a1t. The derivative of the second guy is 4 times e to the 40. Now I have to group all of the terms, right? So I group this constant and this constant. So I'm gonna get 2a1 plus a times a0. All right, and I group this constant and this constant times 4. All right, so this gives me a times h1. So this is 16 a1 plus 16 this is a0 t, and here I have 16 a1 t squared e to the 40. Right, so this is a lot of computation. Any questions on this? So all of this is just computation, right? So here I have a function which is of this form. I'm going to take the derivative of this guy. When I take the derivative of this guy, I take the derivative of the first guy times the second guy plus the first guy times the derivative of the second guy. All right, so this is product rule. The derivative of this is, because the derivative of t is 0, so I have the derivative of t is 1, so I can keep this constant here. Right, so I have 2a1 plus 4a0, which is the derivative of t times this constant. Now the derivative of 4a 1t squared is 8a1t, because the derivative of t squared is 2t, all right? The derivative of this guy is 4 times e to the 4t. So at this step, I have this constant. Now I have to group all of the constant together. So I'm gonna group this guy and the constant for a0 here. So the a0 here is times 4, right? So I have 2a1 plus 4a0 plus 4a0 is 2a1 plus 8a0. All right? This one I have 8 times a1 t plus 4 times of this guy. So 4 times of this guy is 8 times a1 plus 16a0 plus 8 times a0. So I have 16a0 plus 16a0, 16a1 plus 16a0. And this constant, I put it there. All right, so in the exam, I will try to find an exercise which is less scary. So this is scary, but it's good for practicing. So let us try to put everything into that equation. All right. So so I have what? I have 2a1 plus 8a0 plus 16a1 plus 16a0 plus 16a1 t squared e to the 40, right? And then I'm gonna minus 7 times this quantity. So I have to minus 7 times of a0 plus 2a1 plus 4a0t plus 4a1 t squared e to the 40. All right? So this is xp second. And this is xp prime. So this is minus 7 xp prime. And then you add with 12 xp. So this gives me t a0 plus t squared a1 e to the 40. All right? Any questions? It's good. This is computation, so you just have to make sure that you don't make any mistake, but the procedure is not is clear, right? So I will try to find something which is less scary than this one in the exam, right? So here you have 12 times xp, right? And then finally you have t plus 5 e to the 40. Questions? So this is the xp that you found in the beginning, right? And then this is minus 7 xp prime. Xp prime is the derivative of this whole term, which is this guy, and you take the derivative of this whole term, you get this one. So what is the next step? Yes?
Can you cancel out e to the 14?
E to the 40, yes. So the next step is that, okay, can you sign the back of the paper? So the next step is that, okay, everything has e to the 40, so I can cancel all of the e to the 40, right? So this is much easier. And right, because you have e to the 40 in all of terms, so you remove e to the 40, and everything becomes this problem, all right? So what is the next step? Yes?
Just distribute the coefficients and then combine
Yes.
the terms.
Yes. Can you say at the back of the paper, please? So the next step is to identify the coefficient, right? So you have to group all of the t squared together, all of the t together, and all of the constants together, and you identify those coefficients with the right hand side. All right. So let's do it. So the first thing I do is I group all of the constants together. This one, and here I don't have a constant, right? So first I'm gonna group all of the constants. I have 2a1 plus 8a0 minus 7a0. Right, so this is the constant. Right, so I group this guy and this guy. Right, so I have 2a1 plus 8a0 minus 7a0. Now I group all of the t. This guy and this guy. All right, so I have 16a1 minus plus 16a0 minus 7 times 2a1 plus 4a0, and I have times t. All right? I'm gonna group all of the coefficient of t. So this is 16a1 plus 16a0 minus 7 times this constant. So this is t. All right? So then I'm gonna group all of the t squared. So I group all of the t squared. So here I guess I miss 12a0, right? So I miss this guy. I have 12a0 as well. T, right? And then I'm gonna group all of the t squared, which is here, here, and here. So I have plus 16a1 minus 28a1 plus 12a1 t squared is going to be t plus 5. All right? Okay. So I explain again. I combine all of the constants. So this is the first term. So this is this. So you combine this, and you get this one. All right? The t will come from here. And here. And here. 12a0. Right? And the leftover is the t squared. So the t squared is 16a1 minus 28a1 plus 12a1. And the right side is t plus 5. So what can you say about this one? What can you say about the coefficient of t squared? Yes?
It's 0?
Yes. So on both sides you see that this is 0, right? Can you sign the back of paper, please? So this is 0. Right? Because 16 plus 12 minus 28 is 0. Right? So which means that the computation are completely okay, right? So here you have 0, and on the left hand side you have 0. Now I'm gonna combine these. I'm gonna get 2a1 plus a0. And I combine everything here, I get 16a1 minus 12, 14a1, you get 4a1. 16a0 minus 28a0 plus 12 is 0. So basically you have something very nice. Yes?
Should it be 2a1? Since 16 minus 14.
So this is 60, here, right, 60 minus 40, yes, 2a1. Thank you. Can you sign the back of the paper, please? Right, so how can I say about a0 and a1? Yes?
A1 has to be a half, and so then we can use that to solve for A0.
Yes, can you sign the back of the paper, please? So here you're going to have 2a1 is 1, right? So this coefficient has to be the same with this coefficient, and this coefficient has to be the same with this coefficient. So you have 2a1 plus a0 is 5. So the first one gives you a1 is 1/2. You plug it into the second one, and then you have 2 times 1/2 plus a0 is 5. So a0 is 4. Right? Right. Clear? Right? So this gives you 2a1 plus a0. This gives you 0, which is good. And this gives you 2a1. Right? So this is 12, 16 minus. It's 2a1. Right? So when you identify the coefficient, you have 2a1 has to be 1. And 2a1 plus a0 is t plus 5. Right? So the first equation gives you a1 is 1/2. The second equation gives you a0 is 4. So what is the form of xp now? Yes?
So it would be t times 4 plus 1/2 t
Yes.
times e to the 4t.
Yes, can you send the micropaper, please? So xp will be t times 4 plus 1/2 t squared e to the 4t. Right? Questions? So what is the second step?
Isn't it just t, not t squared?
T not t squared. Sorry?
Like instead of 1/2 t squared, shouldn't it just be 1/2 t?
So this is t.
On the very bottom.
This is here, right? 1/2 t. This is t times 4 plus 1/2 t squared.
Oh, never mind.
Right? Other questions? So the next step is to solve the homogeneous question that you know, and you add up the two solutions. This is fine. So the questions 5 is always option questions, right? So so if you can solve these optional questions, you get extra points, which is 5 points. So I also put the second practice test online so that you can practice. Basically, the structure of the second test is the same, but in this second test, questions number 4 and question number 5, they're both optional. But in the real test, there's only one optional question. But in the practice test, I gave you 2 optional questions. Right.
When is the test?
Sorry?
When is the test?
Next Thursday.